For this problem, we're looking at saponification of an ester. They're giving us quite a bit of detail. Um, they're telling us the mass and then the amount of sodium hydroxide when we can do the saponification and titration of leftover. So we may need that information. I'm going to go ahead and calculate it because that will help us determine part of A once we get the molar mass. So we can see that A comes apart to form acid B and C. And if we do the calculation for the um, titration, we take the total amount of sodium hydroxide, subtract the amount of HCl used, and we get the amount of base that was actually used for this. So then to calculate the molar mass, we just take molar mass, which is grams per mole, right? And the acid and base were 1 mole per liter back up at the top there. And so we can use that information to calculate what is the molar mass of our compound A. So we take 2 grams, and then we want to get rid of milliliters because in the moles per liter category, we want moles on the bottom. So I'm going to put 1 over the 9.7 milliliters of base used because it's a 1-to-1 ratio. So I can use straight up 9.7 milliliters and then multiply that by the moles per liter. So that's 1 mole per 1 liter. So I'm setting this up to cancel out liters. And then I change the units to agree. And then we end up with 206 grams per mole. If we go back and calculate, I'll just cross out here. Let's see, milliliters cancel, liters cancel, so we get our units. That makes sense. So then we're going to go on. I'm going to rewrite that reaction. And now we can consider some of the other reactions that are occurring. So first of all, they tell us that this ester has no reaction with potassium permanganate. No reaction. And then they also tell us that bromine, ER2, and dichloromethane gives us no reaction. Basically, so that doesn't decolorize, so that's no reaction. That would be used for the discovery of alkenes, so there's no alkenes. On the other side, we found that this material oxidized, K2Cr2O7, so potassium dichromate again, oxidized to acetophenone. And then we were able to take that, NABH4, and go to, if you reduce, you'll get the alcohol. And that's compound D. And then they said compound B was reacted with thionyl chloride to produce the acid chloride. So they tell us that we can now react compound D with the acid chloride from B, and so we made that here. And when we react those two together, RC double bond OCl plus compound D, which is the alcohol from acetophenone, we would get compound A and another compound. So here is compound A. Now, the question is, what's the other compound? Now we need to consider one of the other details that they told us, and that they said that A and B and C were chiral. So that means that B and C have each a chiral carbon to make up two chiral carbons on A. So this will be one of them for sure. So that means that the other compound is going to be the enantiomer. Now the thing that we don't know is this part of A. So this is where the 206 grams per mole will come in handy, because I can calculate how much this weighs and then subtract and find out how much the other weighs. So let's do that. So once we calculate, we find that what's left from subtracting out this portion is that R must be a butyl group. And in order for it to have optical activity, we would have to be attached at one of these positions, so a secondary position. And so that means we can now figure out that A should be, it's no longer R. There's our ester, O, and there's the butyl group. And so now we have the two chiral carbons. When answering this question on Achieve, you have to consistently show one stereoisomer, and then when it asks for the other, you change it up. But you should be consistent in which stereoisomer you identify. Okay, so that's compound A. And so now you know the rest of the story. Now, one of the things that should concern you, because it concerned me, was this part right here. I feel like that compound A with this benzylic position should have reacted here and been oxidized at that position. So I feel like they kind of misled us with this information. This is perfectly reasonable, but there's something strange about that. There's no double bonds. I know, benzene ring, but benzene, remember, doesn't add bromine. And so there's no double bonds, so you should expect no reaction. So this is the sort of, if I were to have a couple of eyes here and raise my eyebrows really high at that, that's how we'd feel about that. Achieve problem 17.